Every smartphone and computer on the planet runs on microscopic components that exist because of a bitter workplace dispute. The origin of modern computing didn't happen in a peaceful research lab. It happened because a group of brilliant engineers absolutely despised their boss. Before these microscopic chips existed, electronics relied on vacuum tubes. These were fragile glass bulbs that controlled electric current, but they were bulky, ran extremely hot, and burned out constantly. The industry desperately needed a solid-state replacement. Enter William Shockley. He was a brilliant physicist and the co-inventor of the transistor, a much smaller, cooler alternative to the vacuum tube. Fresh off a Nobel Prize win, Shockley moved to Palo Alto, California in 1956 to build the future of electronics. Shockley had the raw genius and the absolute authority to attract the best talent in the country. But his abrasive, paranoid Manhattan style created an environment so toxic it forced his top engineers to flee and build what we now know as Silicon Valley. When Shockley opened his laboratory, his reputation allowed him to bypass normal hiring channels. He handpicked the brightest young Ph.D. graduates from across the United States to work at his new California facility. Working for him quickly became a nightmare. He posted employee salaries publicly, secretly recorded phone calls, and micromanaged them to exhaustion. The tension peaked over a technical disagreement. The engineering team wanted to focus on building silicon transistors, which had massive commercial potential. Shockley stubbornly ordered them to work on a highly complex, unproven device called a 4-layer diode. A diode is simply a semiconductor device that acts as a one-way switch for current. The breaking point arrived when Shockley became convinced there was a corporate mole in the laboratory. To find the supposed culprit, he demanded that his staff submit to polygraph, or lie detector tests. His authoritarian corporate rigidity completely suffocated the brilliant minds he had worked so hard to recruit. For the young engineers, executing a mass exodus became their only viable strategy for professional survival. In the fall of 1957, 8 key engineers, including Gordon Moore and Robert Noyce, decided they had taken enough. They realized their collective expertise was incredibly valuable, so they agreed to leave Shockley as a single package deal. They reached out to Arthur Rock, a young East Coast banker, hoping he could find a corporation willing to hire all 8 of them intact. Rock offered a piece of advice that was practically unheard of in the 1950s. Stop looking for a new boss and form your own company. Rock connected them with Sherman Fairchild, a wealthy industrialist, who agreed to provide $1.5 million in funding. With that capital, the group set up Fairchild Semiconductor, just 12 blocks down the road from their former employer. Shockley was completely blindsided. He viewed the resignation as a deep personal betrayal and permanently branded his former employees the Traitorous 8. By securing outside risk capital to build their own hardware company, these 8 rogue engineers accidentally invented the exact business model that defines modern Silicon Valley. Free from Shockley's constant interference, the team immediately shifted their focus. Instead of using germanium, which was the industry standard at the time, they decided to manufacture their transistors using more robust, heat-resistant silicon. The first major breakthrough came from physicist Gene Horney, who invented the planar process. This manufacturing method involved laying flat, protective layers of silicon dioxide directly onto the wafer to shield delicate components. This flat surface allowed Robert Noyce to print thin metal tracks over the protective layer, safely connecting multiple circuit components onto a single piece of silicon. This design became the first commercially viable monolithic integrated circuit, or what we now call a microchip. Armed with the planar process and the integrated circuit, Fairchild Semiconductor rapidly scaled its manufacturing, moving from a small startup to a massive industrial operation, producing highly reliable components for the aerospace and military sectors. By trusting their own instincts over the dictates of an authoritarian boss, the 8 successfully solved the mass production puzzle that had completely stumped their Nobel-winning former employer. Their influence extended well beyond hardware. The group pioneered a unique culture favoring flat organizational hierarchies and offered broad employee stock options, openly rejecting the rigid, top-down rules favored by their East Coast parent company. Eventually, management disputes with Fairchild Camera and Instrument arose. Frustrated by the lack of control over their own division, the founders did what they did best. They rebelled, resigned, and started over. In 1968, Gordon Moore and Robert Noyce officially left Fairchild to build a new semiconductor company entirely on their own terms. They called it Intel. This chart plots the number of transistors on a microchip over time, illustrating Gordon Moore's famous observation known as Moore's Law. He predicted component density would double approximately every 2 years, driving down costs while rapidly increasing computing power. That simple prediction became the driving heartbeat of the entire global technology industry, establishing a relentless pace for continuous innovation that hardware engineers still chase today. The departure of Moore and Noyce triggered a massive corporate diaspora as engineers continuously left to start their own firms, resulting in a large group of tech spin-offs affectionately known as the Fairchildren. This is a microscopic dye photo of the AM1101A memory chip, designed by Advanced Micro Devices, or AMD. AMD is a highly successful offspring of the original 8, a list that also includes the venture capital firm Kleiner Perkins. What started as a single dispute spawned a cascading chain reaction of startups, spin-offs, and high-risk investments that directly trace their financial and technical roots straight back to Fairchild Semiconductor. The Traitorous 8 built the foundational hardware of the digital age, but equally important, they engineered the disruptive, rebel-driven business culture that makes Silicon Valley a trillion-dollar economic engine today.